In this video, we talk about EFA and CFA. So, EFA and CFA, these are the factor analysis part. So, in factor analysis, broadly includes several techniques, but EFA, that is Explanatory Factor Analysis, and Confirmatory Factor Analysis, we call it CFA, are two main principal and most widely used type in the social science research. EFA for exploring factor structure and CFA for confirming it. So this video we talk about the in detail. First we'll discuss what is the purpose of this video. So in this video I explain not just how to perform EFA and CFA, but why they are required, what problem they solve, their role in research, and how they are interpreted. So first, what is the statistic? That is definition. Second, why do we measure it? Purpose. Third, what exactly does it measure? Conceptual meaning. Fourth, what does a high value means? 5. What does a low value means? And 6. Why is this cutoff used? So first we talk about the why do we need factor analysis. In social science, management, education, psychology, and commerce research, many variables cannot be measured directly. Concepts like attitude, satisfaction, perception, trust, intention, usability, and quality are abstract in nature. These are called latent variables. Since latent variables cannot be measured directly, researchers use multiple observe statements, that is items, to measure them. For example, customer satisfaction may be measured using 5-6 statements. However, a fundamental question arises: do these statements truly measure the same concept? Factor analysis provides a scientific answer to this question by examining relationship among observed variable and identifying underlying latent construct. Those, the primary role of the factor analysis is measurement validation. Second, what is the factor analysis? So first we discuss why do we need factor analysis, and now we discuss about the definition of the factor analysis. So factor analysis is a multivariate statistical technique that reduced a large number of observed variable into a smaller number of underlying factors that explain correlation among them. In simple words, factor analysis helps us understand which item belong together and represent the same concept. Third type of factor analysis. So as I mentioned before in the beginning, in factor analysis there are many techniques, but we talk about only today's video EFA and CFA, and those are the principal and most widely used in social science research. So here we discuss EFA, that is Exploratory Factor Analysis, and CFA, Confirmatory Factor Analysis. Both serve different purposes and are used for different stage of research. First we talk about the EFA, Exploratory Factor Analysis. EFA is used when the researcher does not know the exact factor structure in advance. It is exploratory in nature and allow the data to decide the structure. EFA answers the following questions: how many factors exist? Which item belong to which factor? Are some items problematic and should be removed? EFA is usually the first step in the scale development. Why do we need EFA? We performed EFA to identify the underlying dimension of a construct, reduce a large set of items into meaningful factors, remove weak or cross-loading items, ensure unidimensionality of construct, prepare a purified social for further analysis. Without EFA, researchers risk using invalid measurement instruments. Assumption of EFA. Before performing EFA, the following assumption must be satisfied. First, the sample size. A commonly accepted rule is 5 to 10 respondent per items. So in factor analysis, first we check KMO. And what is the KMO? KMO is the measurement assess the adequate of the data for factor analysis by examining the proportion of common variance among variables. Why do we need measure KMO? So in factor analysis, work only if variables share common variance caused by underlying latent factors. KMO checked whether the correlation among variables are strong and meaningful enough to extract factors. Why does KMO actually measure? KMO compares simple correlation, direct relationship, partial correlation, relationship after controlling over other variables. Good factor data, high simple correlation plus low partial correlation. What does a high KMO means? Variable shares substantial common variance. Factor analysis will produce stable and meaningful factors. What does a low KMO means? Variable does not share common variance. Factor analysis will unreliable and misleading. So KMO should be greater than 0.60. If the KMO is less than 0.60, it means our data is not adequate to run the factor analysis. Below the level of correlation pattern are too weak to justify factor extraction. So Bartlett test of the sparsity test whether the correlation matrix is significance different from an identity matrix accepted p-value 0.05. Correlation item should be moderately correlated but multicollinearity should be avoided. KMO measures sampling adequacy, acceptable value as I said before 0.60. Key terminology in EFA. Factor loading showing the strength of the relationship between an item and a factor. Loading should be 0.70 is ideal and 0.50 acceptable. Factor loading definition. Factor loading is the correlation between an observed variable and a latent factor. Why do we measure it? To determine how strongly an item represents a factor. Why does it measure? The contribution of an item to a construct. High loading items strongly reflect the factor. Low loading item weakly represent the factor. Why 0.70? Because 0.70 is equal to 49% variance explained, which is considered strong. Eigenvalue represent amount of variance explained by the factor. So the eigenvalue 1 rule is the commonly used for the factor retention. Eigenvalue definition. Eigenvalue represent the amount of the total variance in the data explained by the factor. Why do we measure it? To decide how many factors should be retained. Why eigenvalue is 1? As factor should explain at least as much variance as one original variable. Commonality represent proportion of variance explained by the extracted factors. Commonality 0.50 is preferred. Let's talk about the definition of the commonality. This is the proportion of variance in a variable explained by all extracted factors. Why do we measure it? To check whether an item is well presented by the factor solution. Low commonality item does not fit factor structure and should be removed. Rotation. Rotation improved clarity of factor structure. Varimax orthogonal assume uncorrelated factors. Promax oblique allow correlated factors. Interpretation of EFA output. Researcher interpreted KMO and Bartlett test, total variance explained, screen plot rotated component matrix. Item with low loading or cross loading are removed to achieve clear factor structure. Let's talk about the limitation of EFA, that is the explanatory factor analysis. EFA is the data driven and lacks theoretical control. Different sample may produce different factor structure. Therefore, EFA result must be validated. Now we talk about CFA, Confirmatory Factor Analysis. CFA is the theory-driven technique used by test whether the observed data fit a predefined measurement model. In CFA, the researchers specify number of construct, item loading on each construct, the software that tests how well the model fit the data. Why do we do CFA? CFA is performed to confirm factor structure struggled by the EFA or the theory. Establish measurement validity, ensure construct reliability and validity, prepare data for structure equation modeling. CFA represents scientific confirmation in research. Role of CFA in research. CFA ensure reliability of the measurement, convergent validity, discriminant validity, overall model adequacy. Without CFA, research find lack of measurement. In CFA, we check the reliability and the validity. So first we check the Cronenberg alpha. And what is a Cronenberg alpha? That is the measurement internal consistency, reliability, indicating how closely related a set of items are. Why do we measure it? Item measuring the same construct must be behave consistently. What does it actually measure? Average inter item correlation. High alpha means item move together and are consistent. Low alpha item are inconsistent and unreliable. Alpha 0.70, below this level measurement error is too high. Important insight: high reliability does not guarantee validity. Reliability: Cronenberg alpha 0.70, composite reliability 0.70. Composite reliability CR, and what is that? This is the measurement, the internal consistency of the construct using the factor loading. Why CR instead of alpha? Alpha assume equal item contribution, which is unrealistic. CR reflect actual item strength. Accepted value 0.70. We talk about the validity, measurement accuracy. So first we'll discuss with the definition. Convergent validity. What is this? This is the assess whether item intended to the measure the same construct are related. Why do we test it? Item must cover towards the same latent concept. Indicators: high loading plus AVE 0.50. Convergent validity factor loading 0.70. Average variant extracted AVE 0.50. Definition: AVE is an average amount of variance captured by construct relative to measurement error. 0.50 why AVE? Because the construct must explain more variance than error. Convergent validity. Convergent validity assess whether the item intended to measure the same construct are related. Why do we test it? Item must converge towards the same latent concept. Indicators: high loading AVE 0.50, discriminant validity square root of AVE, interconstruct correlation. So definition: discriminant validity test whether the construct that should be different are statistically distinct. Why it is critical? Without discriminant validity, interpretation become meaningless. Foreign-Lager criteria. So there are the criteria to measure discriminant validity. The square of the AVE of the construct should be greater than its correlation with other construct. meaning a construct explains its own item better than others. STMT is also the part of the discriminant validity definition. This is the ratio between the construct correlation to within the construct correlations. Why STMT was introduced? Traditional method failed to detect discriminant validity issues. So that's why the STMT introduced. Accepted value 0.85 strict and 0.90 lenient. High STMT constructs are not distinct. So we talk about the model fit indice in the CFA. Model fit in journal definition. Model fit indice how well the hypothesized measurement model reduced the observed data. Poor fit. Theoretically, model does not match reality. Chi-square definition measure discrepancy between the observed and the predicted covariance matrix. So x square greater than 3 indicate good fit. Why sensitive to sample size? Large sample inflate x square value. Measurement discrepancy between the observed and the predicted covariance matrix. So as I said, 3 indicate the good fit. CFI comparative fit indice. Compare proposed model and with null model. CFA 0.90 acceptable, 0.95 excellent. High CFA model greatly improved null model. TLI Tucker likewise index. Definition is a TLI adjust model fit by penalizing complexity. Acceptable 0.90 meaning simpler model are preferred if fit is similar. RMSEA root means square error approximation. Measure model error per degree of freedom. RMSEA 0.08 acceptable, 0.05 excellent. Low RMESA model approximate population well. EFA versus CFA. EFA explore the data without pre-specification. CFA test a theoretical specified model. EFA precedes CFA. Both complement each other. So now it's time to talk about the conclusion of this video. EFA and CFA together ensure the scientific validity of the measurement instrument. EFA explore the structure while CFA confirm it. These techniques are essential for high quality research publication doctoral work. Thank you.